For most of human history, the greatest threat was not having too much food. It was not having enough. Hunger, famine, disease, war, and long periods without reliable food shaped the human body over thousands of years. The human body became remarkably efficient at storing energy. When food was available, the body stored some of that energy as fat. When food disappeared, those reserves could help keep a person alive. This survival system was extremely useful in a world where the next meal was never guaranteed. But today, the same biological system is operating in a completely different environment. Food is available almost everywhere, at almost every hour, and many foods are engineered to be highly rewarding to the brain. The result is one of the most important health transformations in human history. A survival mechanism that once protected humans from starvation has become part of a chronic disease, affecting hundreds of millions of people worldwide. The story of obesity is not simply the story of people eating too much. It is the story of biology, evolution, food systems, technology, hormones, genetics, the brain, and modern society colliding in a way human bodies were never designed to handle. The World Health Organization now recognizes obesity as a chronic, relapsing disease arising from complex interactions between genetics, neurobiology, eating behavior, access to healthy food, market forces, and the wider environment. In 2022, approximately 1 in 8 people worldwide were living with obesity, and global adult obesity had more than doubled since 1990. The medical history of obesity goes back thousands of years. Ancient physicians were already aware that excessive body weight could be connected with poor health. Hippocrates, often described as one of the fathers of medicine, wrote about the relationship between body size, food, physical activity, and illness. But ancient societies did not understand obesity in the way modern medicine does today. They did not know about insulin resistance, visceral fat, adipose tissue hormones, the hypothalamus, leptin, or the complex communication network between the gut and the brain. Their explanations were based on the medical knowledge of their time. In many historical societies, a larger body could also represent wealth, power, or access to food. In a world where many people faced hunger, the ability to accumulate body fat could sometimes be seen as a sign of prosperity. Yet even in ancient medicine, the idea that excessive weight could damage health was not completely unknown. Historical medical writings discussed diet, physical activity, and weight control long before modern laboratories existed. The important difference was that obesity was often treated as a matter of personal behavior or discipline, while the biological mechanisms behind it remained invisible. For centuries, the basic medical explanation was simple. People became overweight because they consumed more food than they used. That explanation was not completely wrong, but it was incomplete. Body weight is influenced by energy intake and energy expenditure, but the human body is not a simple machine that can be controlled by willpower alone. The brain constantly monitors energy stores, hunger, satiety, stress, sleep, hormones, and environmental signals. The body can also respond to weight loss by increasing hunger and changing energy expenditure. This is one reason why obesity research gradually moved away from the idea that obesity was simply a moral failure. Scientists began to ask a more important question. What systems inside the body control hunger, fullness, fat storage, and energy use? During the 19th and 20th centuries, scientific medicine began to change the way obesity was understood. Researchers started studying metabolism, hormones, genetics, and the role of the brain. They discovered that fat tissue was not simply passive storage. Fat cells could communicate with the rest of the body. The pancreas produced insulin, a hormone that helps regulate glucose and energy storage. The digestive system released signals that influenced hunger and fullness. The brain received information about the body's energy reserves. Slowly, obesity began to look less like a simple problem of behavior and more like a disorder involving multiple biological systems. The history of obesity research eventually developed around several competing ideas, including energy storage,
hormonal control, genetics, the brain, appetite, and energy balance. Modern research shows that these systems are not separate. They interact continuously.
One of the most important discoveries in the history of obesity happened in the laboratory. Scientists studying unusually obese mice found that their extreme weight gain was connected to a biological defect. In 1994, researchers led by Jeffrey Friedman at Rockefeller University identified the gene responsible for producing a hormone later named leptin. Leptin is produced primarily by fat tissue and sends signals to the brain about the body's energy stores. In simplified terms, fat tissue can communicate with the brain, and the brain can use that information to help regulate appetite and energy balance. The discovery of leptin changed obesity research forever because it provided powerful evidence that body weight was influenced by biological signals and genetics. Obesity could no longer be explained only as a failure of self-control. But the discovery of leptin also revealed something more complicated. In many people living with obesity, the problem is not simply that the body has no leptin. Instead, the brain may become less responsive to the signals that are supposed to indicate that sufficient energy is already stored. This concept is often described as leptin resistance. The result is a complex biological situation. Fat stores may be high, but the brain's regulation of appetite and energy balance may not respond normally to the signal. This discovery helped scientists understand that the body can actively defend a higher body weight through changes in hunger, appetite, and energy expenditure. The body is not always trying to become thinner. From an evolutionary perspective, the body is often more strongly programmed to defend against starvation than against excess calories. Inside the brain, one of the most important control centers is the hypothalamus. It receives signals from hormones and the digestive system and helps coordinate hunger, fullness, temperature, stress responses, and energy balance. Another hormone, ghrelin, is strongly associated with hunger signals. Other signals from the gut can communicate that food has entered the digestive system. The brain also responds to the reward value of food. This is where the story becomes even more complex. Eating is not controlled by one single switch. Hunger can be driven by biological need, while cravings can also be influenced by memory, stress, emotion, smell, taste, habit, advertising, and the reward system of the brain. A person may eat because the body needs energy, but a person may also eat because food is available, highly rewarding, socially expected, emotionally comforting, or constantly promoted. These systems can overlap, making obesity far more complicated than a simple decision to eat or not eat. The modern obesity epidemic developed alongside enormous changes in the environment. Human biology evolved in conditions where food was often difficult to obtain, and physical movement was necessary for survival. Modern life changed that equation. Industrial food production made food more available, more affordable, more convenient, and often more energy dense. Transportation reduced the need for daily walking. Work became more sedentary for many people. Entertainment moved indoors. Food became available around the clock. The human body remained biologically adapted to an ancient environment, while the modern environment changed dramatically in a relatively short period of history. The result was a mismatch between ancient biology and modern conditions. The World Health Organization describes this broader interaction between biological, environmental, social, and market forces as part of the complex causes of obesity. The most important change may not be a single food or a single invention. It is the total environment. A person can now encounter food advertisements, restaurants, delivery apps, vending machines, packaged snacks, sweetened drinks, and highly processed foods throughout the day. The brain evolved to notice calorie-dense foods because they were valuable for survival. In the modern environment, those ancient reward systems can be repeatedly activated. This does not mean every person responds to food in the same way. Genetics, sleep, stress, medications, income, culture, access to food,
physical activity, and health conditions all influence risk. That is why two people can live in the same environment and experience very different changes in body weight. Obesity also changed the organs of the body. Fat is not simply stored under the skin. Visceral fat can accumulate around internal organs, particularly inside the abdomen. This type of fat is metabolically active and can release signals that influence inflammation and metabolism. When excess fat accumulates in the liver, it can contribute to metabolic dysfunction and fatty liver disease. When the body becomes less responsive to insulin, blood glucose regulation can become more difficult, increasing the risk of type 2 diabetes. Excess body weight can place additional strain on the cardiovascular system and is associated with increased risk for several serious chronic conditions. The exact risk varies from person to person, but the important scientific point is that obesity can affect multiple biological systems at the same time. It is not only an issue of appearance or body size. It can influence organs, hormones, metabolism, inflammation, and cardiovascular health.
The heart can also be affected. When the body is carrying a greater amount of tissue, the cardiovascular system may need to work harder. Obesity is associated with increased risk of high blood pressure and cardiovascular disease. The kidneys can also be affected by changes in blood pressure, metabolism, and the workload placed on the body's filtration system. The respiratory system may be affected as well, especially when excess tissue influences breathing during sleep. The musculoskeletal system carries the mechanical burden of additional body weight, which can contribute to stress on joints and movement limitations. This is why obesity is now understood as a disease that can involve the entire body, rather than a condition affecting only one organ. The liver is another important part of this story. The liver processes nutrients, regulates metabolism, and stores energy. When excess fat accumulates in the liver, metabolic problems can develop. For many years, fatty liver disease was strongly associated with alcohol, but doctors and researchers increasingly recognized that metabolic dysfunction and obesity could also contribute to fat accumulation in the liver. This led to a major change in how doctors understood the relationship between body fat, metabolism, and liver health. The body systems connected to obesity do not operate independently. The brain, liver, pancreas, muscles, fat tissue, heart, and digestive system communicate through hormones, nutrients, and chemical signals. One of the most important scientific lessons from obesity research is that the disease is not identical in every person. Some people have a strong genetic predisposition. Some gain weight after changes in medications, sleep, stress, illness, or physical activity. Some experience changes in appetite regulation. Some have endocrine disorders or rare genetic conditions that can dramatically affect body weight. Some live in environments where healthy food is expensive or difficult to access. Others are surrounded by highly processed foods and have limited opportunities for physical activity. The word obesity describes a health condition, but the biological pathway leading to it can differ greatly from one person to another. This is why the old idea that obesity is simply a problem of laziness or weak character has become scientifically outdated. Personal behavior can influence health, but behavior itself is influenced by biology and environment. Hunger is biological. Satiety is biological. Hormones are biological. Sleep affects appetite regulation. Stress affects eating behavior. Genetics influence susceptibility. The food environment influences exposure and availability. The modern understanding of obesity does not remove personal responsibility. It explains why the disease can be difficult to prevent and treat. Scientific understanding replaces blame with biology. The history of obesity also reflects the history of medicine itself. For centuries, doctors focused primarily on visible symptoms. As science advanced, researchers began to examine what was happening inside the body. The microscope revealed cells, biochemistry revealed hormones, genetics revealed inherited risk, brain science revealed neural circuits. Modern imaging allowed researchers to observe organs and fat distribution in greater detail. Obesity research moved from a question about body size
to a question about how the entire body regulates energy. The discovery of leptin was a turning point because it showed that fat tissue communicates with the brain. But it was only one piece of a much larger puzzle. Scientists continued studying hormones, neural circuits, digestive signals, genetics, inflammation, and the microbiome. Research revealed that the regulation of body weight involves a complex network rather than a single cause. The more scientists learned, the clearer it became that obesity could not be explained by one hormone, one food, one gene, or one lifestyle factor. Today, obesity has entered a new era of treatment and public debate. New medications that influence appetite and metabolic signaling have changed the conversation around weight management. Drugs that act on pathways involving hormones such as GLP-1 have attracted enormous public attention because they can reduce appetite and produce substantial weight loss in many patients. But their popularity also created new questions about long-term treatment, access, cost, side effects, weight regain after stopping treatment, and the difference between cosmetic weight loss and medical treatment of a chronic disease. The modern treatment era is not the end of the history of obesity. It is another chapter in a story that began with ancient survival biology and continues through modern neuroscience, genetics, endocrinology, and medicine. The biggest lesson from the history of obesity is that the human body did not suddenly become weak. Human biology was shaped by a world of scarcity. Modern society created an environment of constant availability. The same system that once helped humans survive famine can now become overwhelmed by continuous access to energy-dense food and reduced physical demands. But biology is not destiny. Understanding the disease creates better opportunities for prevention, treatment, and medical care. The history of obesity is therefore not a story about blame. It is a story about survival, evolution, science, and a rapidly changing world. Ancient humans fought to find enough food to survive. Modern humans are often surrounded by more food than the body needs. Between these two worlds stands the human brain, trying to regulate hunger, reward, energy, and survival using biological systems that evolved long before supermarkets, fast food, food delivery, and ultra-processed foods existed. And that is why the history of obesity is still being written. The disease began as a question about body size. Science transformed it into a question about hormones, genes, brain circuits, organs, metabolism, and the environment. The discovery of leptin showed that fat could communicate with the brain. Modern research continues to reveal how the gut, pancreas, liver, muscles, brain, and adipose tissue work together. And today, medicine is moving toward treatments that target the biology of appetite and metabolism rather than simply telling people to eat less. Obesity is one of the clearest examples of how human progress can create new health challenges. The same technological and industrial changes that made food more available and life more convenient also created an environment in which ancient survival biology can contribute to chronic disease. Understanding that history is essential because the future of obesity treatment will not be built on one simple solution. It will be built on better science, better medical care, healthier environments, and a deeper understanding of how the human body actually works.